Okay. So am I audible? Fine. Fine, everyone. So hello, everybody. A very something better, something new. All right, everyone. So example, people who are in from the farthest end of the country, so that they can study, they can do something useful, they can do something productive in their life. And to help you do so, we are here. My dear students, all that we want is your support, your cooperation, and your benefit. For your benefit, we want your support and cooperation. Okay. And now, my dear students, the topic for today is coloring and cutting of cubes. Yes, my dear students, the topic for today, the agenda for today is coloring and cutting of cubes. See, from the last 3 to 4 years, if you will introspect that what is coming in the exam from the topic of dice and cubes, obviously one is dice, that is very much coming in the exam, and we've already done dice. We've already done dice over here. The second thing which is very important after that is coloring and cutting of cubes. Coloring and cutting of cuboid is also there, but that is seen in rarest of the rare exams. But coloring and cutting of cube is very important. So today, I will not say that we will be doing question discussion, because most of the things I will explain you. Many students time and again they have messaged me, they have said that sir, please discuss this topic once. So what I would be doing today, this would be a short and informative session. I would be discussing all the basics, all the concepts and all the formulas, and I will show you the credibility. It means basically I will verify all the formulas. So it will not be a thing which I will ask you to just mug up anyhow. No, I will never do that. But yes, I will explain you the credibility of each of the formulas, and I will explain you why and how that formula is coming. Okay, everyone. Now see, have a look at this. The thought of the day. The thought of the day is difficult roads lead to beautiful destinations. Yes, my dear students, difficult path does not mean that everything is wrong. No, your destination will be equally worth of it. So if your path is full of obstructions, difficulties, problems, do not worry. Your end point will be equally, you will enjoy that, you will love that, you will be proud of that. All right. So do not worry. Where there is a will, there is a way. Where there is a will, there is a way. Time can be consumed for making small houses. Okay, few months are consumed. Okay, but for constructing a big palace, okay, years might be consumed. Do not worry. Okay, and now have a look at this. Coloring and cutting of cubes. Coloring and cutting of cubes. You can see a few dots over here. Okay, so have a look at this. A cube being formed. Now, my dear students, let us discuss some of the things of cube which is very much important, because the topic's name is coloring and cutting of cubes. So obviously we must know the basics of cube. The basics of cube are as following. Rajkumar Gupta, Jai Hind, and welcome, my dear student. Welcome. So now please have a look at this. There are some things which you must keep in mind in this topic. And what are those things? See, number one is how many vertices are there. How many vertices are there in the cube? Vertices means corner points. How many corner points are there? So you can already see 1, 2, 3, 4, 5, 6 and 7 and 8 corner points. 1, 2, see this one. Have a look at this. Getting it? It is like this also. It is like this also. In this manner. Okay. So now if you count the vertices, how many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8, and vertices are 8. All right. So how many vertices, how many corner points? 8. Now let us talk about the number of edges. Let us talk about the number of edges. Okay. So if I talk about the number of edges, so edges, let us do the counting. Edges, let us do the counting. Okay. Now if we do the counting of the edges, how many edges we will see? Let us check. Let us explore. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means the edges will be 12, and that is what you can see over here, edges 12. So edges would be 12. So vertices, that means corner points, are 8, edges are 12. And now if I talk about the faces, faces would be 6. How? Let me show you. See, in a cube, remember that there are 6 faces. In a cube, remember that there are 6 faces, and on each of the face there are different numbers from 1, 2 till 3, 4, 5 and 6. So 6 faces, 6 different numbers. Alright, you can see the top and bottom face, the left and right face, the front and back face. So these 6 faces can also be written as 3 pair of opposite faces. I repeat, these can also be written as, very important, 3 pair of opposite faces. 3 pair of opposite faces. Alright everyone, getting it everybody? Yes or no? Yes or no? Yes or no guys? Quickly tell me. Fine. So these are the things which you must know, and I am very sure that all of you are already aware of this. You all are not new. Now what happens in coloring and cutting of cubes? As the name suggests, we color the surfaces of the cube. And thereafter we cut them. But obviously when you will color a cube, fine. And then when you will be cutting a cube, numerous small cubes will be formed. Have you seen a Rubik cube? The Rubik cube is the cube where you make the same colors on all the surfaces. Okay. Yes, RL Sharma. Yes. Now, my dear students, have you seen a Rubik cube? Now, Rubik cube in itself is a bigger cube, but it has numerous small cubes over there. Isn't it, my dear students? So just keep that in mind. And now have a look at this. Okay, before that, my dear students, now let me explain to you how to join our app, because how to join our app is very important. Many students have been asking about it. So how to register our app, every detail. Have a look at this. So at the Google Play Store, click on search for Exampur official app. On the Google Play Store, search for Exampur official app. Over there, a button of install will be there. Just click on that. Now when you will be clicking on that icon of install, such a interface will appear where our logo will be there, and you have to register over there. Let's register, which is also called sign up. Over there you will have to enter your basic details or credentials like name, date of birth, email, password, phone number, state, city. You have to click in the checkbox and then click on register. After that, such an interface will appear which will say welcome to Exampur पे स्वागत है, and then further few lines are there which says सपनों की इस जंग में आपका स्वागत है. हम हैं Exampur, कलम से क्रांति, revolution by the help of pen. Okay. Now my dear students, after that you can just avail all the benefits from here. Okay, all the batch details, the free classes, the paid classes, quizzes, everything, job alerts, everything will be right here at this place. Getting it, yes or no? Getting it, yes or no, my dear students? Okay. Now have a look at this. My dear students. Now, as I said that this is a 3x3 cube. Cube is obviously the length, width and height all are same. Okay. Now, over here, my dear students, let us take the length of cube as 3 centimeter and the length of cut as 1 centimeter. Over here, the length of cube as 4 centimeter and length of cut is 1 centimeter. Okay, and now my dear students, we find out a prime value x. We find a prime value x which is given by, or which can be calculated by, length of the cube upon length of the cut. Length of the cube upon length of the cut. So now my dear students, length of cube is 3 centimeter divided by length of cut is 1 centimeter. X value 3 you will be getting. Here length of cube is 4 centimeter and divided by length of cut is 1 centimeter. So this upon this 4 you will be getting. Yes or no? Yes or no? If length of cube was 4 centimeter and length of cut was half centimeter, then x value will become 8. If length of cube was, for example, 8 centimeter and length of cut was, you can take 0.5 centimeter. 0.5 means 1 by 4. So this will be what? This will be what? Tell me. 8 4 ja 32. 8 4 ja 32 centimeter. Alright, x value will be 32. Isn't it? Fine everyone? Yes or no? Yes or no? Yes or no? Quickly tell me. Okay. Now moving ahead. Now what are the type of questions which can be asked over here? What are the type of questions which can be asked? See, basically there are 5 kind of questions. Now see, please understand my dear students. Now we would be coloring the cubes. Okay. To begin with, we will cover what we will do: top and bottom with any one color, left and right with any one color which is other than the top one, and front and back with any other color which is different from the others. So I should repeat. For example, top and bottom with red color. Okay, for example, top and bottom with red color. Okay. Then my dear students, left and right, for example, with blue color. All right, with blue color. Fine. So this is blue color. Or let me write it in a more better way. For example, if this is red color, red. Okay. Now with blue color. So this is with blue. And now this with, for example, green color. Green. Okay. Now if this is red, the bottom is also red. If this is blue, the right side is also blue, and if this is green, then here also is green. Okay. Similarly here also. Now what are the types of questions over here? The very first question over here is number of small oblique unit cubes. Now how to verify this thing? Now let me give you an example. My dear student. Now the example over here is this. Okay. The example over here is this. Suppose this is a block of paneer. Okay. And in this block of paneer, now if we are doing the cutting. So this is now one block of paneer. Now if I take a knife and cut it in this manner. Now 2 halves or 2 paneer pieces will be there. Again I took a knife and then do the cutting in this manner. 4 pieces will be there. Again I took it in this manner, knife, and cut it in this way. So 8 pieces will be there. So 1, 2, 3 and 4 will be in the top layer, and 1, 2, 3 and 4 will be in the bottom layer. To total 8 layer. Total 8 blocks of paneer will be there, isn't it? How? I just now said, my dear students, that suppose if you take a slice of paneer, and if we use a knife, so now 2 pieces of paneer, 2 more pieces of paneer, and now total 8 pieces. How 8 pieces? See, 1, 2, 3 and 4. Okay. Fine everyone. This is in this layer, and in this layer also 1, 2, 3 and at the back side. Okay, fine everybody, yes or no? Yes or no? So that is why total 8 pieces will be there. And now let me take this as 2 centimeter length of cube, 2 centimeter length of cube and 1 centimeter length of cut. 2 centimeter length of cube, 1 centimeter length of cut. So length of cube upon length of cut, length of cube upon length of cut, it's 2. And now in order to find the number of smaller cubes, in order to find out the number of smaller cubes, we have the formula x cube, which is 2 cube. 2 cube is equal to 8. 2 cube is equal to 8, and here 8 blocks of paneer were there or not? 8 blocks of paneer were there or not? Yes or no? Quickly everyone. Fine everybody? Fine. Rajkumar, now I don't have answer to this question. Maybe some problem from my end. I will try to correct it. Okay, RL Sharma, Rajkumar Gupta. Okay, so now I hope it is very clear. So this formula is verified, the credibility is seen. Okay, so now for this particular question, okay, for this particular question, this is a bigger cube which has been cut into smaller cubes, so many cubes will be formed. Again, this is a bigger cube which has been cut into very smaller cubes, so many cubes will be formed. Okay, so now how many will be formed? So here it is given by number of smaller cubes is given by x cube. And what is x? Length of cube upon length of cut. Length of cube upon length of cut, x value is there, and now x cube is 3 cube, which is 27. Here also, my dear students, length of cube upon length of cut, x value is 4, and the moment you put 4 over here, 4 cube will be 64. So here 27 smaller unit cubes will be formed. Here 4 cubes, 64 smaller unit cubes will be formed. Is it clear? Fine everybody? Yes or no? Yes or no? Quickly confirm, my dear students. Quickly confirm, please tell me yes or no. Yes or no? Yes or no? Quickly tell me, my dear students, yes or no? Anyone having any doubt? Anyone having any doubt, please tell me. Okay, so now we will be moving ahead. Now we will be moving ahead, and now we will be solving some of the further things over here. So now please have a look at this. Okay, before that, how to get the demo? My dear students, that's very important, how to get the demo, because many students often ask me this question that, sir, that we want the demo of this. So see, have a look at this. In order to get the demo, you will have to again visit our app. Over there, our icon is there of free classes. Click on that icon of free classes. The moment you click on that icon of free classes or free course, at the top SSC, police exam, UP special, teaching, banking, etc. will appear, in which you have to click on SSC. The moment you click on SSC, my dear students, the moment you click on SSC, the things will appear in front of you. Okay, the moment you click on SSC, the details will appear in front of you. Okay, and now over there you will see what all courses are running, what all courses are going. Now on that, if you just view the course, on that if you just view the course, my dear students, then you will get every detail, like the subjects, the faculties, the study plan, which faculties will teach you, at what date, at what time they are going to teach you. Every class, every detail you will be getting. All right everyone? Fine everybody, yes or no? Fine everyone, yes or no? Quickly tell me. Okay, now with these words we are moving ahead. Okay, and now let us come to this, the next question. Getting it? Any doubt so far? Any doubt so far? Yes or no? Any doubt so far? Yes or no? Okay, now see, now what it is asking you, number of small cubes having 3 face painted, number of smaller cubes having 3 face painted. Now see, let me take, these are red, 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 okay, in this manner. Okay, now these are blue, 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 and so on. These are blue, and now suppose these are green, suppose these are green. Okay, now my dear students, in this figure only you should check. It is telling you number of smaller oblique unit cubes having 3 face painted. So 3 face painted. Now have a look at this. For this cube, only 2 faces are outer, at outer end. So we can touch only 2 faces, we can color only 2 faces. For this face, this cube, for this cube, only one face is at the outer end, so we can only touch that and paint that. For example, if I am asked to paint a wall, I can only paint the wall which I can see. I can only paint the wall which I can see, Behind this, I cannot see, I cannot do anything. All right, because I cannot touch that. I hope you are getting this. All right, everyone. So you can paint only that wall, or you can color only that wall which you can see and then simultaneously touch it. Okay, you are sitting right now in a room and listening to my lecture. So if suppose you have a closed room, the door is locked, you can only paint the interior of the walls. Out of the wall you cannot paint because you cannot go outside. Similarly, the same thing will happen over here. So such cubes like this one, for this only two faces are at the outer end, so we can touch and paint only two of them. For this cube also only two faces are there at the outer end, so we can touch and paint only two. For this cube only one face is there at the outer end, so we can touch and paint only one. I hope you are getting this. Now for those cubes which three faces can be painted, are over here, one with red, one with blue, one with green. And such cubes whose three faces can be painted, for them the three faces are at the outer end, and that is why they can be painted. We can touch them, we can paint them or color them. So such cubes whose three faces can be painted are always found one at the vertex, at one corner point 1. So total at 8 corner points 8. So this answer is always 8. Here the answer is always 8. In this also, such cubes whose three faces, see this is, now let me do one thing, red, okay, then blue, okay my dear students, blue, and now green, okay, green, okay everyone, fine. Now see, in such cubes, okay, again if I ask you number of cubes whose three faces can be painted, so have a look at this. For this cube and for this cube, only two faces are at the outer end, so we can touch and paint only two of them. For this cube, 1, 2, 3 and 4, only one face is at the outer end, so we can touch and then paint only one. But now for this one, three faces are outer end, at the outer end, so we can touch and paint all of them. So at every vertex 1, so at 8 vertex 8 vertices 8. Getting it everyone? Yes or no? My dear students? Getting it? So that is the right one. So that is why I have written this. Number of smaller oblique unit cubes whose three faces can be painted are always found at the vertices, at one vertex 1. So at total 8 vertices 8. Alright everyone? Clear? Now have a look at this. What can be the other question type which can be asked? It is, see, this much is clear. X is equal to length of cube 3 centimeter upon length of cut 1, so it will be 3. Length of cube 4 centimeter upon length of cut 1 centimeter, x value 4. And now the third question which can be generated over here, the third question which can be asked over here is what? The third question which can be asked over here is number of smaller oblique unit cubes having two face painted. Okay, so now let me prepare the diagram for you. Okay, so this is red, okay, fine, just hold on. And after that blue, okay, blue, and then green, okay, fine everybody, getting it? Now the structure over here, the funda over here is very simple. And now have a look at this. Suppose now it is asking you number of smaller oblique unit cubes having two face painted. Such cubes whose two faces are painted are the ones whose two faces are at the outer end. We can see them, we can touch them, and only then we can paint them. And such cubes are seen at the edges. About this edge, we have one such cube whose two faces are at the outer end, and we can paint them. At about this edge, there is one such cube whose two faces are there at the outer end, we can paint them. About this edge, there is one cube over here whose two faces are at the outer end, we can paint them. So at every edge one is there. At every edge one is there. And how many edges are there? And how many edges are there? 12 are there. At every edge one is there. Such cube whose two faces are at the outer end, and hence you can paint the two of them. And now since 12 edges are there, so at every edge 1, so total at 12 edge 12, so total at 12 edge 12, and therefore the answer for this is 12 over here. Okay. Now if you want to use the formula, if someone wants to use the formula, so it is x minus 2 into number of edges. I can easily write x minus 2 into 12. I can easily write x minus 2 into 12. Okay everyone. Now I am writing this over here, x minus 2 into number of edges. Okay, I am writing it over here, x minus 2 into number of edges. I am writing the formula over here. Okay, x minus 2 into number of edges. Okay everyone, x minus 2 into number of edges. Why? I can easily write x minus 2 into 12 because I know that there are 12 edges in a cube. I can easily write x minus 2 into 12 because I know that there are 12 edges in a cube. You also know that. But knowingly also I wrote number of edges so that it gets into your mind, it penetrates into your mind that such cubes whose two surfaces can be seen, whose two surfaces can be painted are seen about the edges. About every edge 1 over here. So about 12 edges, 12 over there. Now if you use the formula, x value, the prime value is 3. So 3 minus 2, 1. 3 minus 2, 1 into number of edges 12, 1 into 12 is 12, and that is equal to what we are getting over here. Okay. Further, let us check more about this structure, this cube. About this edge, there is 1 and 1, total 2 such cubes whose two surfaces are at the outer end, and hence they can be seen, painted. About this edge, again there is 1 and 2 such cubes whose two surfaces are at the outer end, and hence they can be painted. Alright. About this edge, there are also 1 and 2 such cubes whose two surfaces are at the outer end, and hence they can be painted, they can be touched. So about every edge you are seeing 2 such cubes over here. About this edge 2 cubes, about this edge 2 cubes, about this edge 2 cubes whose two surfaces are outer and or can be painted. Okay. So my dear students, since about every edge 2, about this edge 2, about this edge 2, about this edge 2, so around 12 edges, 24, around 12 edges, 24, and therefore 24 is the answer for this. Now if someone wants to use the formula for this, x value is 4. So the moment it will put 4 over here, so 4 minus 2 is 2, 4 minus 2 is 2 into 12, number of edges 12. So 2 into 12 is 24, 2 into 12 is 24. Alright everybody. Fine everybody. See, 4 minus 2 is 2 into 12 is 24, and that is the right one. That is the right one. Alright everybody. Clear? So I hope you are able to verify the credibility of the formula. Yes or no? See, those who are live must like this session. It's a request. Okay everyone. Fine. Now see, when I say two painted faces or such faces, such cubes where two faces can be painted. Now it can be a combination of red green, it can be a combination of red blue, it can be a combination of blue green. Okay, or any other colors if you have put any other color. So as of now we have done 3 question types. Number 1, how many smaller cubes can be formed. Number 2, such cubes which can have 3 faces painted. Such cubes are always seen at the corners at every vertex 1, so at 8 vertices 8. Then we have done 3rd question, number of cubes having 2 faces painted. Number of cubes having 2 faces painted are seen about the edges in such structure, about every one edge 1, so about total 12 edge 12. About this cube, about every edge 2 such cubes, every 2 such cubes, so at about 12 edges 2 cubes, so total 12 to 24 cubes. Formula also can be verified that for here x value 3 minus 2 into number of edges 12, here 4 minus 2, 2 into 12, 24. So we can verify this, isn't it? Isn't it, my dear students? Next, now my dear students, the next very crucial thing, the next very important thing. My dear students, Have a look at this. How to purchase the course. How to purchase the course. This is very crucial because many students often ask me, sir, how to purchase, from where to purchase, at what price to purchase. Every detail will be over here. So Aryan Gupta, welcome. See, I have discussed with you how to download and install the app. So now what you will be doing there, when you have installed the app, then a paid course icon is visible. Click on that. The moment you click on that icon, the SSC examination is available at the top. The SSC examination is available, Haryana special, teaching special, banking exam, railway exams, all are available. You click on SSC exam. Now there, how many courses which are running, all of them will come. All of them will come. Select the course, CPO course, MTS course, CHSL course, CGL course, whatever you want. The moment you click them on buy course, and then auto applied coupon code will be coming. Auto applied coupon code will be coming over there. Until 21st August, 60% off is going on. So now if you continue to purchase the course or to continue to buy the course, okay, such an interface will appear. You can buy it through cards, through UPI, through internet banking, through debit card. All modes of transactions are available. And the moment you do the payment, the moment green appears, tick mark appears, it's done. It's very simple. It's very, very user friendly. All right, everyone. Now, have a look at this. The next question which can be asked is number of smaller oblique unit cubes having one face painted. One face painted. Okay. Now, again, let me just prepare it for you. Red, red, red. Red, red, red. Then blue, blue. And then green. All right, everyone. Okay. So here two opposite faces are painted red, top and bottom. Two opposite faces are painted blue, left and right. Okay, here also left and right, and two opposite faces are painted green. This one and the left one, this one and the left one, which we cannot see. Okay, everyone. So now if the question is there, number of smaller oblique unit cubes having one face painted. So that means it is asking those cubes in particular. It is asking those cubes in particular where only one face is at the outer end. Where only one face is at the outer end. All right, everybody. So here it is finding those faces in particular where only one face is at the outer end, where only one face is having which we can touch. Okay. So now in this cube, about this cube, if you see this cube, it has only one face which has which is out. Okay, which we can see and touch and paint also. About this face also, there is only one such cube which is at the outer end. Okay, we can see it, we can touch it, color it. About this face also, there is only one such cube which is at the outer end. We can see it, touch it, paint it. So about every face, one such cube is there over here. About every face, one such cube is there over here. So about the 6 faces, 6 will be there. About the 6 faces, 6 such cubes will be there. One at each face, one at each face. So at 6 faces, 6 over here, my dear students. Please have a look at this. About this surface, 1, 2, 3 and 4 such cubes are there whose one face is at the outer end. We can touch them because for this one 3 faces are out, for this one 2 faces are out, for this one 2 faces are out, for this also 3 faces are out, for this 2 faces are out, and so on. So now for them 3 faces can be painted or 2 faces can be painted. Okay, I hope it is clear. So but these are the ones whose only one face is outward. So we can touch them, we can see them, we can paint them. About this also 1, 2, 3 and 4. 1, 2, 3, 4. Such 4 structures are there, 4 cubes are there whose only one face is towards the outer end. Okay, everyone. Here also 1, 2, 3, 4. 1, 2, 3, 4. Only one face is there towards the outer end. We can see them, we can touch them, we can feel them. So about every one face, 4 such cubes are there whose only one face is at the outer end, we can see them, touch them, color them, paint them. About every face 4 cubes, about every face 4 cubes. So about total 6 faces. So about total 6 faces, 4, 6 4 are 24, and that's the one. That's the right answer. That's the right answer. But now, how to go by the formula? The formula says in a very clear way. The formula says in a very clear way that in such cases, number of smaller oblique unit cubes having one face painted is x minus 2 square into number of faces. It's x minus 2 square into number of faces. Alright. So now, and what is x? You are well aware. For this, x value is length of cut upon length of cube. Length of cut upon length of cube, 3. So the moment you place 3 over here, 3 minus 2, 1. 1 square is 1 into 6. 6. See, I can easily write x minus 2 whole square into 6 because I know that the number of faces are 6 in a cube. I can easily write that number of faces in a cube is 6, so I can write x minus 2 square into 6. But I want you to understand, to memorize, to learn that such cubes whose only one face can be painted are the ones which are the ones at the faces, at the center of the face, at the middle of the face. Okay. Now here also if you see, my dear students, all right. Now here also if you see, you can clearly understand this. That about this face, okay. 1, 2, 3 and 4 such cubes are there whose only one face is outer, so we can test them. 1, 2, 3, 4. 1, 2, 3, 4. So total at 6 faces into 4, 24. By formula, what you can do? Length of cube upon length of cut. Length of cube upon length of cut. It's 4. So x value 4. 4 minus 2, 2. 4 minus 2, 2. 2 square is 4. 4 minus 2, 2. 2 square is 4 into number of faces 6 is 24. Into number of faces 6 is 24. Getting everyone? Fine everyone? Fine everybody? Clear everyone? Getting it? So now, formula is verifiable. Formula's credibility has been checked. It has been seen. All right, everyone. Clear, everybody? Clear? Now, Nancy, welcome. Suresh, good morning. So, are you all able to get this? Now, so 4 question types we have done so far. Number 1 was number of smaller oblique unit cubes. Number 2, number of smaller cubes having 3 faces painted. Next, number of smaller cubes having 2 faces painted. Then 4th one, the number of smaller cubes having 1 face painted. And the final one, the last one will be number of smaller cubes having 0 or no face painted. Okay, so now have a look at this and have a look at this. Okay, let me prepare it for you again. Red, 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 red. Okay, here also. And then blue over here. And then green. Now see, my dear students. What is to be understood over here. Such cubes I cannot show you. Whose 0 face are painted. Because if I could have shown you, I could have touched also that. And if I could have touched that, I could have painted that. So if I would have been able to show you that face, I would be able to touch that face. And if I would be able to touch that face, I can paint it, or you can say I can color it, isn't it? But I cannot do that now because such cubes are at the middlemost. Now, since they are at the middlemost, they cannot be seen from anywhere. And since they cannot be seen from anywhere, we cannot touch them, and obviously then we cannot color them. All right, everyone? Fine, everybody? Yes or no? Yes or no, my dear students? Now, please understand this. Then how I will show you this? By indirect way. How? Here, total such cubes were x cube 27. From that we will minus all the cubes which are having colored faces. 3 faces colored were 8. At every vertex 1, so about the 8 vertices 8. Okay. Now, such cubes whose 2 faces can be painted. About every edge 1. about every edge 1, so about 12 edges 12, and then such cubes whose one face can be painted, such cubes whose one face can be painted about every face 1, about every face 1, so about 6 faces 6. And now if you will do this calculation, 27 minus 8 plus 12, 20 plus 6, 26, you will be getting 1. So this is the only one cube at the middlemost which cannot be painted, which cannot be colored. And now here also I can show you, my dear students. See, such cubes, total cubes are 64. The total cubes are 64, and from that we will minus all the colored faces. 3 faces colored, 2 faces colored, and 1 face colored. So now 3 faces colored will be always 8, 1 at every vertex, 1 at every vertex. Okay, at every vertex 1, see 1, 2 and 3, so at 8 vertices 8. Now such cubes whose 2 faces can be painted about this edge 1 and 2, about this edge 1 and 2, about this edge 1 and 2, so about every edge 2. Now since about every edge 2, about 12 edge 24, about 12 edge 24. Alright everyone, fine everyone. And now my dear students, now over here, such cubes whose one face can be painted. See, these are 3 faces painted, these are 2 faces painted, and now 1 face painted. I will tell you. Here also, my dear students, these were 3 faces painted, these were 2 faces painted, and these were 1 face painted. Alright everyone. So here 1 face painted, how you will find out? About every face 1, 2, 3, 4, about this face also 1, 2, 3, 4, about this face also 1, 2, 3, 4, so about total 6 faces, 24. And now when you will solve them, you will be getting 64 minus 56, 24 plus 24, 48 plus 8, 56. And if you will solve them, you are going to get 8, you are going to get 8, isn't it? So this is nothing but simple calculation. It is nothing but simple calculation. And now if you want to use the formula approach, so now my dear students, it is nothing but x minus 2 cube. It is nothing but x minus 2 cube. Alright everybody, it is nothing but x minus 2 cube. Now it is x minus 2 cube, my dear students. So what we can do? Okay, color is not clear. Color is due to color it is not visible. Okay, fine. कलर साफ नहीं दिख रहा है, ठीक है, मैं अभी ब्राइटनेस थोड़ी सी कम करवा देता हूं, तो ब्राइटनेस कम करवा दूंगा तो वो अपने आप सही हो जाएगी चीजें, ठीक है। चलिए आगे देखते हैं, लेट अस सी फर्दर। तो माय डियर स्टूडेंट्स, नाउ हियर वन थिंग, हाउ टू डू इट बाय द हेल्प ऑफ फॉर्मूला। So if you want to use the formula x minus 2 whole cube, x value you know, length of cube upon length of cut. So the moment you do x value 3 minus 2 is 1 and 1's cube is 1 only. So that was the answer. That was the answer. Here x value is length of cube upon length of cut. Length of cube upon length of cut, that means 4. So now 4 minus 2 is 2 and 2's cube is 8. Alright everyone, fine everybody. Yes or no my dear students? Quickly tell me. Getting it ma'am and sir who are watching it live, quickly tell me. Yes? Okay. Nancy, I hope it is visible now. I hope it is visible now. Tell me, color is visible? So, these are the things which are done. Now, every other question which can be asked from this topic is a combination of these 5 questions. Every other question which can be asked from this topic is a combination of these 5 questions. Okay? Okay, so what were, I will just summarize them. X is equals to length of cube upon length of cut. Okay? X, which is the prime value, the functional value, the main value, is length of cube upon length of cut. Now here 5 questions can be asked. Number 1, number of smaller cubes. So number of smaller cubes, if someone asks you, it is nothing but x cube. We have already shown this. Number 2, number of smaller cubes. Okay, number of smaller cubes having 3 face painted. It is always equal to the number of vertices. Okay, and that is always 8. Okay, now Third question. Number of smaller cubes having 2 face painted. It is always equal to x minus 2 into number of edges. X minus 2 into number of edges. Okay, because such cubes whose 2 faces are painted are seen about the edges. Now seen the fourth question. Number of smaller cubes having 1 face painted. Having 1 face painted. Such cubes are seen about the face. X minus 2 whole square into number of faces. X minus 2 whole square into number of faces. Alright everyone? Getting it everyone? Yes or no? Now, finally the last question. The number of smaller cubes having 0 face painted or no face painted. Okay, it is nothing but x minus 2 whole cube. It is nothing but x minus 2 whole cube. So on the basis of these 5 questions, some clever things can be used. How? What do I mean by clever things? For example, if I ask you, how many smaller cubes are there whose at least or minimum one face. See, at least and minimum on one side and at most or maximum on another side. At least or minimum on one side, at most or maximum on another side. So if the examiner asks you, how many cubes are there whose at least or minimum one face is painted? At least or minimum one face means what? 1 face painted plus 2 face painted plus 3 face painted. Okay, at least 1 face painted. See, let me do it in this way. See, here what can be done? Number 1, examiner can ask you at least or minimum 0 face painted. At least or minimum 0 face painted means 0 face painted plus 1 face painted plus 2 face painted plus 3 face painted. Okay, here at most 0 face painted. At most 0 face painted means what? At most 0 face painted means only 0 face painted. Only 0 face painted, that's it. Second thing, at most 1 face painted. Sorry, at least 1 face painted. At least 1 means 1 face painted, 2 face painted, 3 face painted. Here, at most 1 face painted. At most 1 face painted means 0 face painted plus 1 face painted. Okay. Third question. At least 2 face painted means 2 face painted plus 3 face painted. At most 2 face painted. At most 2 face painted means 0 face painted plus 1 face painted plus 2 face painted. Okay. Okay. Fine everybody. Thank you. Nancy. Thank you Nancy. I will try to correct it. I will try to improve it. Okay. But content, I hope you are getting it, what I am trying to explain. Now here, if the next question is, that fourth question is, at least or minimum 3 faces are painted. At least or minimum 3 faces are painted means only 3 faces painted. At least or minimum 3 faces are painted means exactly 3 faces are painted. Okay, and now here, at most 3 faces are painted means 0 face painted plus 1 face painted plus 2 face painted plus 3 face painted. Not more than 3 faces can be painted. Okay. For any cube, not more than 3 faces can be painted. Are you all getting this? Are you all getting this? So do not get confused with the word at least and at most. At least and minimum are similar. At most or maximum are again similar. So at least 1 face paint, my dear students, at least 0 face painted means 0 face plus 1 face plus 2 face plus 3 face painted. But at most 0 face painted means 0 face only painted. Now, alright everyone, have a look at this. At least 1 face painted. At least 1 face painted means 1 face painted plus 2 face painted plus 3 face painted. Alright everybody. And here, at most 1 face painted. At most 1 face painted means 0 face painted plus 1 face painted. Here, at least 2 face painted means 2 face painted plus 3 face painted. And over here, at most or maximum 2 face painted means 0 plus 1 plus 2 face painted. Here, at least 3 face painted means 3 face painted. Here at most 3 faces means 0 plus 1 plus 2 plus 3 faces painted, and so on. Alright everybody, fine. So with these words, my dear students, we come to an end of the session. I discussed many formulas today. For example, number of smaller cubes is equal to x cube. it was verified also. Number of smaller cubes having 3 faces painted is equal to number of vertices, okay, which is always 8. This was also verified. Number of smaller cubes having 2 faces painted, which is equal to number of edges multiplied by x minus 2, okay, and number of edges is 12. You all already know. I could have written into 12 over here, but I left it because you should be clear that such cubes whose 2 faces can be painted are seen about the edges. Finally, my dear students, such cubes whose 1 face can be painted, such cubes whose 1 face can be painted is x minus 2 whole square into number of faces. I could have written 6 over here easily, but why I wrote 6? Because 6 into x minus 2 whole square, 6 is the number of faces over here. 6 is the number of faces over here, okay, and I want it to be clear in your mind that such cubes are seen about the faces. Finally, such cubes whose 0 face can be painted is x minus 2 whole cube. It is x minus 2 whole cube, okay. Fine everybody? Yes everyone? Yes or no? So today we discussed the basics of this, but in the very next class I will use these terminologies in the next class of this topic, not in the tomorrow's class. Next class of coloring and catching of cubes, I will use these words, mix of them, combination of different colors, and I will try to make this further difficult and interesting. It will clear your doubts also. I am very sure the concepts will get sorted out. Alright everybody, fine everyone, clear? Number of cubes with 3 faces painted is equal to number of vertices. Number of cubes with 2 faces painted about edges, okay, so it is x minus 2 into number of edges. Alright everybody, number of cubes having 1 face painted about faces, okay, fine everybody, fine everybody. Now number of cubes having 0 face painted. I hope you are getting this. Now with this we come to an end of the session, and I request all of you, my dear students, that please come get enrolled in our paid batches. In our paid batch, we have launched the paid batch for SSC, CPO, CGL, CHSL all-in-one foundation batch, where you will be getting daily live classes, PDF notes, practice sessions, structured study plan, test series, and 60% off only till 21st of August. 60% off only till 21st of August. All right, the price is 2,999. After applicable of this discount, it's 1,199. All right, everyone. And now, if you have any query, any issue, any difficulty, any discussion, please feel free to call on this number or WhatsApp on this number. Call on this number, WhatsApp on this number. And now, if you got everything in the class today, please write on the comment box all clear. Please write in the comment box all clear at the end of the class. All right. Thank you, everybody. Have a great day.